Okay, so let's say I have a triangle, an oblique triangle. And what am I referring to when I say oblique? It does not have a 90-degree angle. It's not right. Okay, so the thing about the law of cosines is you would want to use that rule if you don't have a pair. Remember, a pair is an angle measure and the side length across from it. So in this triangle here, if I were to have this is 29 degrees across from 10, and I knew this other side was 8. Okay, just throwing out some numbers there. I could absolutely solve this triangle using the law of sines. Remember, that was just a proportion. But let's say I don't have a pair, and then I have to use the law of cosines. So let's go ahead and remember what that was. Somebody give me 3 letters I can use to name this triangle. Well, let's use something besides ABC because that's what's in our notes. XYZ, okay? Or CDE, there you go, so that's some good ones. So let's say X, Y, and Z. So this would be side X, this would be side Z, and this would be side Y. Remember, we use the uppercase letters for the angle measure. We use the lowercase for the side lengths. So let's say I wanted to write out the law of cosines for side Y. So the side I start with, I'm going to go ahead and square it. But does anybody remember what am I going to do to the other 2 sides? I have to square and add them. Okay, so I'm going to say x squared plus z squared. Now what?
2xz.
Minus 2 times their product. So minus 2 times x times z. And then how would I finish that up? Times the cosine of angle y. Yes. Remember, one of the patterns we talked about when dealing with the law of cosines, whatever side length you start with, you're going to end the equation with that angle measure. Okay, that's directly across from it. Okay, and let's see exactly where we were on this problem. It says a triangular lot has sides of the 120, 186, and 147. Okay, find the angle across from the shortest side. Okay, and it looks like we got that taken care of. Okay, the angle we're looking for would be across from the smallest side. How would I know which one is the largest angle? There you go. You're looking for the angle directly opposite or across from the largest side. So it doesn't ask for it. So why don't we go ahead and figure out what that is? Let's go ahead and use this as a review problem. Okay. So we already figured out the smallest angle. Well, let's go ahead and figure out the largest. Okay. And let's go ahead and use the law of cosines. Even though I have a pair now, we want to work with the law of cosines for a little bit. So let's say this is theta. Okay. So think about what we just set up. What side length is going to have to start my equation if I want theta? It's got to be 186. You always start with the side across from it. So I'm going to say 186 squared equals. Now what do I do with the other 2 sides? Square them and add them. So 120 squared plus 147 squared. Now what? Okay, now we subtract 2 times those 2 sides. So 120, 147 times the cosine of theta. I just went ahead and called it theta so we know exactly what angle we're talking about. Okay. Now, what we want to do is solve this for cosine of theta so that I can plug this in the calculator, let it take care of all that work for us. We just need to go ahead and manipulate it. Remember, yesterday I showed you to do this in 2 steps. First, these individual terms, we want to go ahead and subtract those over. Okay, so I'm going to have 186 squared minus 120 squared minus 147 squared equals, see, all I did was just subtract those 2 over, and it'll be the same way every time. Negative 2 times 120 times 147 times the cosine of theta. Okay. Well, now what am I going to do to get cosine of theta by himself? I'm going to divide, very good, by this product coefficient we have here. So negative 2, 120, 147. Same thing over here. Negative 2, 120, 147. So see, these are all going to cancel. So this expression right here is going to end up being cosine of theta. Okay. Is everybody with me? All right. Well, let me go ahead and plug this guy in the calculator. Let's see what we end up with. We have 186, 120, and 147. Let me get rid of these. So control divide. We have 186 squared minus 120 squared minus, is it 147? 147 squared. And then we're going to have that over negative 2 times my 120 times my 147. Okay. So that expression that we came up with, I just want to get a decimal value. So I'm going to push enter. Okay. Now, if we want to go ahead and go for the decimal, we can convert it. This one looks like it just simplified it for me, 157 over 3920. And we can go ahead and still work with that. Okay. Or does anybody want me to get the decimal? Okay. So 157 over 3920. 157 over 3920. And here's the big difference. I'm looking for the angle measure given the side lengths. Okay. Every time you're looking for an angle measure, you have to take the inverse. So what I'm going to do here, okay, I'm going to take the inverse cosine of that ratio, and that's going to give me theta. That's going to tell me exactly how big that angle is. Okay. Now, as far as what we do in the calculator, well, that's pretty easy. All right. I'm just going to go to trig. Remember, that's right next to 7. And you'll notice in the second row, this is where all your inverse trig functions are. So I'm just going to go ahead and type in cosine inverse. I'm going to highlight the previous one, or you could type it in again if you want to. But now I'm going to go ahead and push enter. So I'd say that angle is probably about 87.7. Okay. About 87.7 degrees. There we go. Just like that. Okay. Now remember, once you have the first angle, and my piece of advice, if you're going to start with the law of cosines, always go ahead and start by finding the largest angle first. Okay. I could use the law of cosines to find another angle like we did here, or I could revert back to the law of sines. Okay. Even on this last angle, I could go ahead and use the law of cosines or the law of sines to find this remaining one. But at this point, what would probably be the easiest thing? You could use law of sines, but what's something easier I'm referring to? Yeah, I know that all three of them have to add to 180, so I could just take the two I have and subtract from 180. Brandon? Yes, because every time you evaluate a trig function, okay, it works like this. Like, let's say we're dealing with cosine. Okay. If I go ahead and input an angle measure, okay, what it's going to give me is the ratio of the sides of a triangle. Okay. You remember when we were evaluating, in fact, that's exactly what we're doing on our happy minutes. Okay, every time we plug in one of those radian or those degree measures, okay, we're finding the ratio of the sides of a triangle, right? A right triangle that was created. Well, if I already know what the sides of the triangle are, but I want to go ahead and work backwards, remember we have to take the inverse. Because what's the inverse have me do with those two quantities? It always has me switch them. Remember, the basic idea was that the x values become the y's and the y's become the x's. So if I want to work backwards and figure out what the angle measure is, well, I'm going to invert it. So I'm going to input the ratio of the triangle sides. Okay. And what I should get out as an answer is my angle measure. Okay. The only time you need to take an inverse trig function is when you're looking for an angle measure. Okay. If you're just looking for a side length, you will not be taking the inverse. Okay. But all we're doing is just flipping the two quantities. Okay. Is everybody okay with that? Okay. Not too bad, not too bad. Okay, well, let's go ahead and look at another problem. Of course, I would have the answers up here. La, 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 la. Pay no attention. La, la, la. Okay. So let's pretend when I clicked on that slide that there was nothing right there. Okay, we just have this triangle. All right. Now, this is not in your notes. This is just an extra example that I wanted to go ahead and give you guys before we, move on. So let's say we have this one, and I want to know everything there is to know about this triangle. Well, what's the only items I have missing? Yeah, we only need to know the three angles, right? And then we're done with the problem. Well, can I use the law of sines? Why not? There you go. We don't have any of the angles to begin with, so we don't have a pair. You can only use the law of sines if you have a pair. Okay, so this is the type of triangle I'm going to have to use the law of cosines with. Okay. Now, what was my one piece of advice? Always start with the largest angle. Would that be A, B, or C? C. How do I know that? Yeah, C is across from the largest side, right? So let's go ahead and find C first. So I need to write out that equation using the law of cosines, but starting with 16. So somebody tell me what I should write. Oh. So we got to start with 16 squared equals. Okay, now we take the other two sides. Remember, we square them and do what? Add them. Then we subtract 2 times 11 times 9 times the cosine of angle C. Okay? It's always the same pattern. Now, let me ask you a question. We're trying to find C. Will I have to take the inverse? Yes, because we're trying to find an angle. If you're trying to find an angle measure, you'll need to take the inverse. Okay, well, let's just do exactly what we did a moment ago. Is it an emergency? It is an emergency? I know, I'm just kind of messing with her, making her wait. Yeah, go ahead. Okay. She didn't think that was too funny. Anyways, let's go ahead and do exactly what we did a moment ago. What would be the first step to get cosine of C by itself? Okay, so these two individual terms, we're just going to subtract them over. So 16 squared minus 11 squared minus 9 squared equals the negative 2 times 11 times 9 times the cosine of C. Okay, now what? Then we divide by what's in front, this product here. So negative 2, 11, 9. Negative 2 times 11 times 9. So see, all of those cancel. Cosine of C now equals this expression. Okay. So now let's just plug it in the calculator. From here, the calculator is going to take over for us. All right, so let's see. Get rid of this, document B. So control divide, we started with 16 squared minus 11, not 111, squared, minus 9 squared. That is not right. There we go. And then we're going to divide it by negative 2 times 11 times 9. Okay. So for this, I'm getting negative 3 over 11. Okay. Is that what everybody's getting? Now remember, this is what cosine of C equals. Negative 3 over 11. Okay. Yeah, so we don't know what angle C is giving me, but I do know that the ratio of the sides of the triangle are going to be negative 3 over 11. So now I'm going to take the inverse. So cosine inverse of that value I got is now going to give me the angle I'm looking for. Okay. And some of you probably already done it, but let me catch up to you. So I'm going to choose cosine inverse. I'm either going to type in or just highlight that previous value. So I'm getting, let's say 105.8. Is that what everybody's getting? Okay. Good, good, good. 105.8 degrees. Perfect. Perfect. Now, here's where you have a choice. Okay. What did I just give myself? You now have a pair. Okay. You can continue to choose to work with the law of cosines if you want to, or now that you have a pair, you could use the law of sines. What would you guys like to do? You want to go law of sines? Okay. Okay. So because I have angle C now, that's how I'm going to start my expression. So sine of 105.8 degrees over 16. Well, now what I'm going to go ahead and write next depends on what angle you want. We want A, so how would I write it? Just 11 over A? Sine A, there you go, because remember, we're looking for the angle. So this would be sine of A, because we have no idea what angle A is, over 11. So let me ask you a question here. Will I be taking the inverse? Yes. How do I know? Because what am I looking for? Remember, if you're looking for an angle measure, you're going to be taking the inverse. If you're just looking for a side length, no inverse. Okay, well, how do I solve a proportion? Yeah, you're still going to cross multiply. Okay, so this is going to give me that 16 times the sine of A is equal to 11 times the sine of 105.8. Well, how do I get sine A? Yeah, go ahead and divide through by 16 now. Those are going to cancel. So I know that sine of A is equal to this right here. Okay. And I know some people are probably saying, well, Mr. West, if you go ahead and plug it in with the 105.8, since we rounded it, won't that affect our answer? Okay, well, it will, but that's why I'm going to go ahead and do this. I'm going to hit Control Divide. We have 11 times the sine. Oh, thank you, Rhett. But instead of just putting in the 105.8 that we rounded to, I'm going to, again, use that value that's already in the calculator. Okay, so it's going to make my final answer more approximate. And I think we were dividing this by 16, right? Okay. So let's say I get a 0.661. Okay. So sine of A is equal to 0.661. That's what this expression came out to be. Well, how does that help me find angle A? Take the inverse. Okay. So sine inverse of that value I just got is going to give me A. Okay, so let's see what that is. Trig. Now this time, because I have sine, I want to make sure and hit sine inverse of that previous decimal. Okay. And who can help me out? What degree measure should I see when I push enter? Okay, I heard 41.4, and that is exactly what we're getting. Okay, 41.4, yes. Okay. And what's the only thing I have left on the problem? Yeah, we just got to find B. So we can add those up and then just subtract that from 180, right? So let's see here. I'm just going to go ahead and take the 180 minus the 105.8 we just found, minus the 41.4. So I'm finding angle B to be 32.8. There you go. So this is the law of cosines. Now, even though we finished up this problem using the law of sines, was anybody having difficulty with the law of cosines? Anybody not sure where a value was, came from, where you got it? Okay. All right. Well, I'll tell you what, we're going to go ahead and stop there for